All right, section 7.1, angles of polygons. Okay, in this section, in this chapter, chapter 7, we step it up a notch. Up until this point, for the most part, we've been talking about no more than three-sided figures. Okay, in chapter 7, we start talking about four-sided and more-sided figures. There are figures that have more than three sides. Okay, we've got our four-sided, five-sided, pentagons, hexagons, octagons. Okay, so we're going to start talking about those now. So in this lesson, our objective, use the interior angle measures of polygons. Okay, use the exterior angle measures of polygons. Okay, so we're actually going to have a polygon interior angles theorem that we'll get to here in a minute. But first, let's discuss what is a polygon again. A polygon is a figure made up of segments. It's segments connected at their endpoints. To create a closed figure. What we mean by closed is once you're inside, you cannot get out. Okay. For an example, closed would be something like this. Open would be something like that. Okay. Open. Here, these are segments connected through endpoints, but it's open. You see, we can kind of get in or out here. Okay. A segment is made up of sides and vertices. So we have sides like this one over here. We called this polygon A, B, C, D, E. We list it by its vertices. We always go around when listing the vertices. We wouldn't go A, C, B, D, E. Okay, we always go around, normally clockwise, but you could go counter and it still be okay. But we would call this polygon A, B, C, D, E. We list all its vertices, again, in order going around. So really all of the triangles that we've been dealing with, those were polygons as well, okay, because they're made up of segments connected at their endpoints, okay. So, but a triangle is a special type of polygon. It's a polygon with three sides, okay. So, just a little review of our polygons. We talked about them way back, chapter maybe 2, I think. We did triangles, hexagons, octagons, quadrilaterals, okay, all of those different shapes. So we'll need those words again now, okay. All right, so so we have our polygon, okay. We also have one new word, a diagonal. A diagonal is a segment that joins two non-consecutive vertices, meaning it's going to join B. If I'm drawing diagonals from B, it's going to connect B to the vertices that aren't right next to it. I wouldn't connect B to C. That's not a diagonal, but I could connect B to D and B to E. Those are both diagonals. So from B, I can draw in two diagonals. Okay. All right, so we're going to look at our different polygons here, and we're going to draw in some diagonals. Okay, so let's start by drawing. Here we have a triangle. It's got three sides. Okay, and we're going to go ahead and let's look at, if I was to draw all the diagonals in from here. Well, if I'm drawing all the diagonals in from this point, well, diagonal there, nope. Those aren't diagonals. It has no diagonals. It forms one triangle. We have our one triangle. And it has an angle sum. If I add up all three of these angles, the angle sum is 180, 180-degree angle sum. Okay. All right, so you might be wondering, like, well, no, duh, it only makes one triangle, but let's go ahead and let's look at this next one. Okay, let's draw all the diagonals in from this point. Okay. So let's draw all the diagonals in from that point. Okay. Okay, first of all, so there I drew in the one, that's the only diagonal I can draw in from that point. If you notice, this is made up of, this is a four-sided figure. It's got four sides. The name for it is a quadrilateral. Okay. I have one diagonal. I could draw the one diagonal from this point. Okay, I could draw multiple diagonals from other points, but there's only one diagonal from this point. But how many triangles did that make? If you notice, we've got this triangle here and this triangle down here. So it makes two triangles. So it makes these two triangles. And if you notice this top triangle, if I was to add up all these angles, I'd get 180 degrees. But if I was to add up now all these angles down here, we'd also get 180 degrees. Okay, so it makes two triangles, but if I was to put all of these angles together, this one up top, this whole one here, this one down here, this one down here, do you see that I would actually get 180 for these angles here, these pieces, 180 for these pieces, so I'd actually have an angle sum of 2 180 degrees. So we'd have 2 180 degrees, which is 360 for an angle sum. Okay. We're going to try to notice a bit of a pattern. Let's do it again now here with a shape that has 1, 2, 3, 4, 5 sides. So this has got 5 sides. We call a 5-centered figure a pentagon, 5-sided figure a pentagon. Again, let's draw all the diagonals from this point. Okay. So how many diagonals does this make? It will make, let's see, there's one diagonal there. And then we've got this one here. So I can draw in 2 diagonals. Okay, 2 diagonals. But if you notice then it makes 1, 2, 3 triangles. Okay. So the 3 angles in this triangle are going to add up to 180. The 3 angles, this one, and this one, are going to add up to 180. And the 3 angles here are going to add up to 180. So the total angle sum would be 3 times 180, because these 3 angles here add up to make this big one, these 2 add up to make that big one, these 2 add up to make that big one, and then we have those 2 angles. So then I'd have 3 times 180, which is 540 degrees for an angle sum. Okay. Right now let's go 1, 2, 3, 4, 5, 6-sided figure. 6-sided figure we call a hexagon. Okay, so now let's go ahead and let's draw in all the diagonals from, let's say, this point right there. From that vertice, let's draw in all those diagonals. So it's going to make, we'll have 1 right here, 1 right here, and then 1 down here. So there's our 3. It makes 3 diagonals. Okay. Which then makes 1, 2, 3, 4 triangles. So again, this triangle, the angle sum in this one's going to be 180. This one's going to be 180. This one is going to be 180. And this one down here is going to be 180. But all of these triangles together make, all these angles together here make one angle. These 2 angles make that one. These 2 make that one. These 2 make that one. So I would actually have 1, 2, 3, 4 times 180, okay, to get my angle sum. Okay, 4 times 180. I don't know that one on the top of my head. That one's 720 degrees for an angle sum. Okay. I'm wondering, is anyone noticing a pattern? As we go up a side, what I'm wondering, is there a pattern between the number of sides and the number of triangles made? 3 sides makes 1 triangle with 1 180. 4 sides makes 2 triangles, which makes 2 180s. 5 sides makes 3 triangles, which makes 3 180s. 6 sides makes 4 triangles, which makes 4 180s. So let's go hypothetically over here. Let's say I had a 12-sided figure. If it's got 12 sides, is there a way for me to find its angle sum? Well, if it's got 12 sides and I draw in the diagonals, it's going to make how many triangles? Okay? I want you to think about that for a second. Okay? So I want you to go ahead and write that down, what you think that would be. Okay, and then catch me in the next video.